Hello, welcome to the help video for homework number 17. This comes from page 42 in your workbook. Problems G, H, J, K, and M. I know it's kind of bouncing around there. You should see on your screen a copy of this. I wrote down the problem already, so I didn't have to waste time in the video doing that. So I'm going to use different strategies for this. For the first one, for G, I'll use the distributive property. Some of you might not need to write all these out the way that I am to get your answers. Maybe you just draw arrows, especially when you're doing a binomial times a binomial. You don't necessarily need to write all this out like this, but I'm doing it so I can show the work that's being done. All right, so for the first one, 10W times 10W is 100W squared. 10W times 1, well, that's easy. That's 10W. Now, when I multiply the second binomial by -1, it's basically going to negate everything, make it the opposite of what it is. So I have -10W and -1. All right, so now when I look at my like terms, I have 10W and -10W, and those cancel. So 10W minus 10W is 0. So all I'm left with for an answer, 100W squared minus 1. And that is your final answer for G. Moving on, H. Okay, this one should be pretty simple. It's the distributive property. You might be saying, well, I'm used to it being in the front. Well, okay. Using the commutative property of multiplication, we can flip this around. And when we do that, it looks like this. And we get W squared times -5W is -5W cubed. Notice that the exponent increased here because there's another W. W squared times -3 minus 3W squared. These are not like terms, so that is the final answer. Moving on. Okay. Let's try the, let me see if I can choose a different shape here. The geometric area model here. I've got a binomial times a binomial. So I'll slice this vertically and horizontally, okay? And then I'll put my first binomial here on the width side, or the length, whatever you want to call it, 2q plus 1. The other one over here, 2q squared plus 1. And now I'll fill in the middle. 2q times 2q squared is 4q to the third power. 2q times 1, well, that's just 2q. I know my q's look a little funny. Sorry. 2q squared times 1. 2q squared. And then 1 times 1 is 1. Do I have any like terms? No, I do not. So in standard form, 4q cubed plus, I know, terrible, 2q squared plus 2q plus 1. So we have a 4-term polynomial. So just to kind of recap, we did a binomial times a binomial, and we got a 4-term polynomial. In the beginning, we did a binomial times a binomial, and we got a binomial. So don't always assume that you're going to get a certain type of answer. A lot of times when we do a binomial and a binomial, we'll end up with a trinomial, okay? But not always. All right, so for this one, let's do, how about this? I'm going to use my commutative property of multiplication again and do x minus 1. X minus 1 times x squared minus x plus 1. And I switched it around so I could do the double distributive property. And by that, I'm going to do x times all of that trinomial. And I'm going to do -1 times all of that trinomial. Let's hope I didn't make any copying errors. Okay, let's work through this. So x times, let's pick a different color here. Let's go green. X times x squared, that's x cubed. X times -x, -x squared. Yes, watch your sign. X times 1 plus x. Now, -1 times all of this is going to negate or make it the opposite. So -x squared. -1 times -x is plus x. -1 times 1 is -1. Any like terms? Yep, we got a couple. We've got -x squared and -x squared. We have plus x and plus x. So when I combine my like terms, I get -x squared and -x squared. That's -2x squared. There's two of them. Just like there's two x's minus 1. So I have a 4-term polynomial written in standard form. There is my final answer. Put a box around it. Last problem. How am I doing on time here? I'll check it at the end. Okay, this looks a little tricky at first. You're like, geez, Mr. Decker, oh no, what do I do? Real simple. First, we'll multiply the first binomial times the second binomial, and I'll use the double distributive property the quick way. T times t, t squared. T times 1, 1t. -1 times t, -t. And -1 times 1, -1. My like terms are t minus t, so I have t squared minus 1. Now I'm going to bring this other binomial down and multiply my answer from up here, t squared minus 1, times that. And when I do, t squared times t squared is t to the 4th. T squared times 1, t squared. -1 times t squared. Hopefully you're seeing a little pattern here. And -1 times 1. Hey, look at that. Middle two terms cancel out or zero out. T to the 4th minus 1. What an interesting answer for that last problem. Okay, now, if you don't believe me, not sure if I did it right, check your answers with the key. Oh, look at that. Is that a mistake? Mr. Decker forgot to put the answer to M on the answer key. So you would actually have to watch this video to hear me say that, but I noticed that mistake earlier. I'll be interested to see how many of you bring that up in our algebra class. If you do, of course, whenever you spot a mistake and bring it up, we get some points on our scoreboard. So please do that. I hope this makes sense, but if you have any questions or you're still confused, please reach out and ask questions in class, and I will help you if I can. Good luck, and I'll see you in algebra.